The constant speed of light should not be treated as the second key postulate of relativity. Relativity holds true regardless of whether or not the speed of light is constant. This postulate is simply redundant for the theory. From the first postulate, we can conclude that all particles must share exactly the same maximal speed limit. The limit can be either of a finite value or of infinite value. The discovery of the violation of the classical speed addition law in many situations is a direct evidence of a finite value for the speed limit in the universe. The constancy of the speed of light should be treated as a hypothesis, subject to experimental verification. Up to now, nobody is absolutely sure about the statement due to accuracy limitations of existing apparatus and quantum vacuum fluctuations that interact with the movement of a photon. There are two key postulates in Einstein's special relativity. Postulate number 1, the laws of physics remain the same for all uniformly moving frames. Postulate number 2, as measured in any inertial frame of reference, light is always propagated in empty space with a definite velocity c that is independent of the state of motion of the emitting body. There are two important logical consequences for the first postulate. Consequence number 1, a common maximum speed limit. All free objects must share exactly the same maximal speed limit. Otherwise, the principle of relativity is violated. Consequence number 2, the constancy of the speed at the limit. If an object travels at the common maximal speed limit in one inertial frame, it must travel at the same speed in all inertial frames. That is, its speed is constant in this case. The limit can be measured experimentally. It makes no sense physically to have an infinite value for the speed limit. If any particle wave needs a medium to propagate, it must have an finite value for its maximal speed limit, determined by the stiffness of the medium. Based on the constancy of speed at the speed limit as the second logical sequence of the first postulate, we can derive the Lorentz transformation, a key transformation in special relativity, just like Einstein did in 1905, which was based on the constancy of the speed of light. There is no need to postulate the constancy of the speed of light here. It simply doesn't matter if the speed of light is constant or not to have the principle of relativity to hold true. Using the constant speed of light as the second postulate to explain relativistic effects such as time dilation, length contraction, and loss of simultaneity could be confusing to the general public. Oftentimes, people mistakenly thought it is the cause of those relativistic effects. But the truth is that we have those relativistic effects as long as the common maximal speed limit is of a finite value. In other words, we suffer from time dilation and length contraction as long as the common maximal speed limit is of a finite value, regardless of whether or not the speed of light is constant. Taking the constant speed of light as the second key postulate of special relativity confuses almost everyone, including Einstein. Violation of the classical speed addition law is a direct evidence of the existence of a finite speed limit. To be more specific, assume that there is an object moving with speed v in one frame. Assume that we jump to another frame which is moving in the opposite direction of the object at a speed u relative to the first frame, and measure the speed of the object in the second frame. If we find out the speed is not v plus u, then the classical speed addition law is violated. It suggests there is a finite speed limit for the object. People have found in many situations that the speed of light is a constant, independent of the speed of the observer. The constancy of the speed of light is a direct evidence of the violation of the speed addition law. It suggests the existence of a finite speed limit. It also suggests that the speed limit is the speed of light in vacuum. The constant speed of light should be a hypothesis subject to experimental verification. Up to now, nobody is sure about the constancy of the speed of light. Neither Maxwell's equations, nor the Michelson-Morley experiment can tell us the constancy of the speed of light because they are not exactly accurate. All existing apparatus also have a limit in accuracy at measuring the speed. Recently, it has been found that spatially structured photons in free space travel slower than the speed of light. Vacuum isn't really empty, but is filled with virtual particles. A virtual particle pair can pop out of the vacuum for a very short time interval then disappear. Light will interact with those virtual particles. At present, nobody knows if the interaction with virtual particles in vacuum will slow down light from its maximum speed limit.